All right, hi folks. I'm recording a video for Section 8.3, and this has to do with a concept called Law of Cosines. So you might remember in Section 8.2, we worked with Law of Sines. And we also made use of the fact that all three angles in a triangle must add up to 180 degrees, and that allowed us to solve different examples and applications using Law of Sines. But it turns out there are some applications where law of sines just doesn't work, meaning you don't have enough information to solve a problem using law of sines. When that happens, we could use law of cosines as an alternative. Let me give you an example. Let's say you knew the lengths of three sides of a triangle, and you wanted to find, let's say, the missing angles. Well, if I come here to law of sines, notice I would know side A, know side B, and know side C. But if I didn't know any of the angles, law of sines would not work. Remember, to use law of sines, you have to be able to write one fraction equal to another fraction where you know three of the four unknown quantities. But in my example, we couldn't set sine A over A equal to sine B over B, because we only know two of the unknown quantities. So law of sines would not work there. So what we do instead is we look at law of cosines, which are these three formulas shown here. And let's do an example to get started. And for these examples, we'll try to use law of sines. And I'll show you that for our examples here, law of sines might not work. So we'll use law of cosines as an alternative. Remember, law of sines and law of cosines can be used for non-right triangles. We call those oblique triangles. All right, let's take a look at this example here from the 8.3 homework. So they're giving us this triangle, and they want us to solve the triangle. Remember, that means find the missing angles and missing sides. Okay, so you might notice that two angles are unknown. We don't know angle A, we don't know angle C, and also one side is unknown, side B. So those are three unknown quantities that we need to determine here, okay? Remember, I can't use sine theta equals opposite over hypotenuse. That only pertains to a right triangle. I can't use Pythagorean theorem. That only pertains to a right triangle. Maybe I'll try to use law of sines. So let me try to use law of sines here. So I'm going to write down sine A over A equals sine B over B equals sine C over C. And my suggestion was circle the information that you know and see where you end up. Well, let me label this triangle. I'm going to label this angle as angle B. This side here is side A, that's 5. This side is side C, that's 6. All right, so it looks like I know angle B, so I'm going to circle that. I know side A, I'm going to circle that, and I know side C, I'm going to circle that. But notice law of sines doesn't work here in this example because I don't know 3 out of 4 unknown quantities if I was to try to write an equation. For example, if I was to set these two fractions equal to each other, it would not be enough because I only know 2 out of the 4 unknown quantities, so I could not solve this problem using law of sines. So let me go to law of cosines instead. Now, when I look at law of cosines, I notice these 3 equations each have a certain angle specified. Notice for angle 1, they show it as angle C. Equation 2 uses angle B, and equation 3 uses angle A. Well, in my example, we know, or we're given angle B. And we want to find side B to begin with. Well, if I'm given angle B, notice that suggests I should use equation 2 here. So let me write it. Equation 2 says B squared equals A squared plus C squared minus 2AC cosine B. Okay, so let's go ahead and plug in. We know everything on the right side of this equation. Side A is 5, side C is 6, and cosine B here is cosine 30 degrees. Okay, so let me figure out B squared. And again, I'm going to let my calculator do some of the work here. I'm going to type in this entire expression in the red box here into my calculator at one time. This way I don't have to write down any intermediate results. So I'm typing this in all on one line in my calculator. I'm also double checking that my calculator is set in degree mode. All right, if I type this in my calculator, I'm getting that B squared is 9.0384. And actually, let me actually give you a little shortcut. Instead, what I'm going to do here is write it as a square root to make it even easier. So I'm going to write B as the square root of 5 squared plus 6 squared minus 2 times 5 times 6 cosine theta. And now I'm going to let my calculator do all of this at once. So I'm going to type this into my calculator now. It's just a time saver to avoid having to, work this problem one piece at a time. And when I do this, I'm getting that B is 3.006. They want me to round to 2 decimal places. So it looks like our answer is B is 3.01. Okay, so now we know side B is 3.01. All right, well, let's go ahead and try to figure out some of these other angles now. Well, I just noticed that we figured out side B. Well, now we do know 3 of the 4 unknown quantities, so I could use law of sines now. So let's write it, because I want to find angle A as the next step. So let me write law of sines. It's going to be sine A over side A equals sine B over side B. Okay, so this is going to be sine A over side A, which was given as 5. And that's equal to sine B, but that's sine of 30 degrees, over side B, which we just figured out is 3.01. All right, I'm going to cross multiply. And that means sine A times 3.01 is equal to 5 times sine 30. I'm going to divide both sides by 3.01. And that's going to leave me that sine A equals, I'm going to work this out on my calculator. So I'm going to be working out this box on my calculator. 5 times sine 30 divided by 3.01. And so I'm getting that sine A is 0.83056. Now I'm going to take the inverse sine to get angle A. And if I do that, I'm getting angle A is 56.157 degrees. Let me enter the answer for side B so we can see the rounding instructions. The angle, so I'm going to enter side B, we figured out was 3.01. Okay, now it's asking us to round this to 1 decimal place. So angle A we figured out is 56.2 degrees, rounding to 1 decimal place. Angle C now, I can use the fact that we have now 2 angles in the triangle known. So angle C is going to be 180 minus 30 degrees minus 56.2 degrees. And so if I work that out on my calculator, I'm ending up with the answer of 93.8 for angle C. All right, so we had to recognize for this example that We couldn't use law of sines to begin with because we didn't really have enough information to apply law of sines. We went to law of cosines. We decided that because they gave us angle B, then our equation 2 was appropriate because that's the only equation that involves angle B when it comes to law of cosines. All right, let's go to another example here. Let me jump to another example. All right, let's take a look at this one. And again, they're asking me to solve the triangle. So I know that means find all sides and all angles. Well, I'm noticing in this example, they gave me all sides, but I need to find the 3 angles, angles A, B, and C. Of course, once I know 2 angles, I'll be able to figure out the third using the fact that all 3 angles have to add up to 180. All right, again, maybe I'll try to use law of sines. Well, if I circle what I know side A, I know side B, I know side C. But notice I don't have enough information to use law of sines, right? Because I could not write an equation where I know 3 of the 4 unknown quantities. So I need to go to law of cosines. All right, well, I need to figure out either angle A, B, or C to begin with. So it's really going to be up to me to use whatever one of the 3 formulas I want. Let's use the third formula. Let's find angle A first. I don't have to do it that way, but I'm going to find angle A first because that's the first answer my math lab is looking for. So let's find angle A. So I'm going to use the third equation that says A squared is equal to B squared plus C squared minus 2 BC cosine A. All right, let me plug in one I know because I know all 3 sides. Let me just label this. Side A is 7, side B is 3, and side C is 5. Okay, so let's plug it in. Side A is 7, so this is 7 squared. Side B is 3, side C is 5. So this is going to be minus 2 times 3 times 5 cosine A. Got to be a little careful solving this because I know I got to follow order of operations here. So let me work this out. That's going to be 3 squared is 9, 5 squared is 25. This is 30 cosine A. Okay, let me keep going. 9 plus 25 is 33. Let me subtract 33 from both sides. And that looks like 16 equals negative 30 cosine A. And remember, I want to get cosine A by itself. So I'm going to divide both sides of this equation by negative 30. So I'm ending up with cosine A equals negative 16 over 30. All right, well, I can use the inverse cosine function on my calculator. And so that means that cosine A is negative 0.5333. That means angle A is inverse cosine of 0.5333. I'll do this on my calculator. And I'm getting the answer of angle A is 57.769 degrees, but they want me to round to 1 decimal place, so 57.8 degrees. All right, so I know angle A. Now we need to find one other angle. And again, I can either use angle B or C now. I'm going to use angle B. It doesn't matter, but let me draw that up here. So now I'm going to go to formula 2 from law of cosines because that will let me figure out angle B. I'm going to do it the same way. So let me go ahead and write that. So when I use formula number 2, it says b squared is a squared plus c squared minus 2ac cosine b. Let me plug in all the sides because I know all the sides of this triangle. So this is going to be 3 squared. Oops, I just realized I made an error here. This should have been negative 0.5333. Let me go back and fix that. Whoops. Apologize for that error. So I need to figure out inverse cosine of negative. And that's an important difference because that's going to give me a totally different angle. So now I'm coming up with the angle for angle A as 122.2 degrees on my calculator. Okay. Remember, I had negative 16/30, which was negative. So I had to take the inverse cosine of negative 0.533. All right, let's go back then. Let me plug into this law of cosine formula. Side A here is 7. Side C is 5. And let me get cosine B by itself. So this is going to be 9. I'm going to add 49 plus 25 on that side. That's 74. Now I'm going to subtract 74 from both sides of this equation. And when I do that, I'm getting negative 65 equals negative 70 cosine B. So that means cosine B, I'll divide both sides by negative 70, is negative 65 divided by negative 70. And when I work that out on my calculator, I'm getting positive 0.92857. Now I'll take inverse cosine of both sides. So B is inverse cosine of 0.92857. Go to my calculator to solve for angle B. It looks like angle B turns out to be 21.8 degrees, and I'm rounding to 2 decimal places. Well, the last step is find angle C, but that's going to be the easiest part of this problem because now that I know angle A and B, I'm just going to subtract those angles from 180. And when I do that, it looks like angle C turns out to be 36 degrees. Okay, quick double check. I could make sure that these 3 angles do add up to 180 degrees, of course. If they didn't add up to 180, I know I must have made a mistake somewhere. All right, so we used law of cosines here. Again, we tried law of sines, but that didn't work. So we used law of cosines, and we were able to figure out angle A to begin with. Then we found angle B. Then we could use the fact that the 3 angles add up to 180 to find the third angle, angle C. All right, let's enter this. So angle A we figured out was 122.2 degrees. Angle B, whoops, let me double check. Folks, let me go back and just double check my calculations here. Whoops, I see a typo. Let me fix this. Whoops. I made a very small arithmetic mistake. So let me go back and fix this here. 9 plus 25 down here should be 34. So let me fix all of this. So this should have been a 34. My apologies. So then I'm subtracting 34 from both sides. So then this should have been a 15 here. That's going to change this angle. So bear with me 1 second here. We'll fix this. And so this should have been 15 over negative 30. So this is going to be negative 0.5. So angle A is inverse cosine of negative 0.5. So this angle is actually 120 degrees. So this is 120. And then that's going to change angle C to be 38.2 degrees. All right, let's try that and see if that fixed it. So this answer should have been 120. And then we found angle B was 21.8. And then angle C is 38.2. And again, these three angles should add up to 180. Okay? All right, apologize for that typo there. But I think you can see the general setup of how to apply law of cosines. All right, why don't we do an application problem for law of cosines? Let me go to this example here. Let's read this one over. All right, so this one says a golfer hits an errant tee shot that lands in the rough. So it looks like here is the ball. A marker in the center of the fairway is 160 yards from the center of the green. And it says, while standing on the marker and facing the green, the golfer turns 105 degrees. He then can walk off 35 yards to the ball. How far is the ball from the center of the green? All right, well, first thing to do here, as in any of these problems, is to draw and label a diagram. So let me kind of draw a diagram here to mimic this setup. Right here's the ball. And I'm going to label this triangle as A, B, C. By the way, you could label it using, you don't have to label it the same way I do, right? You could put angle A up here at the top if you want, but you do have to label the sides correspondingly. So if this is side A, if this is angle A, I've got to label the opposite side as side A. So that means that's side B and that's side C. All right, well, they're telling me that side B is 160. Side C is 35, and I know angle A is 105 degrees, and side A is the unknown quantity. All right, let me try to see if I could use law of sines. All right, I know side B, I know side C, and I know angle A. Notice I can't use law of sines, because I can't set one fraction equal to another where I would know 3 of the 4 unknown quantities. So it looks like law of sines is not applicable here. So I'm going to go to law of cosines instead. Should I use formula 1, 2, or 3? Well, in our example, we know angle A. So the only formula that involves angle A is the third formula. So I'm going to write it A squared is B squared plus C squared minus 2 BC cosine A. Let me plug in what we know. Side B is 160. Side C is 35. And cosine A is cosine 105 degrees. Okay? But of course, we want side A. We don't want A squared. So side A is going to be the square root of this whole expression. And I'm going to let my calculator do this all at one time by typing this entire expression, including the square root symbol, on into my calculator. And that'll give me answer A. It looks like they want me to round to 1 decimal place. So I'm going to my calculator. And again, folks, notice we tried to use law of sines in this example, but we weren't able to. So we went to law of cosines, and then we decided to use formula number 3 because that formula involved angle A, which is the angle we were given in this problem. All right, so when I enter this square root into my calculator, I'm getting the answer. A is 172.405. They want me to round to one decimal place, so it looks like our answer here is this ball is 172.4 yards away from the center of the green. All right, let's try that and see if that's the correct answer here. All right, folks, hopefully this is useful as you are working in the 8-3 homework. And again, these are the 3 important formulas to keep in mind when working with law of cosines.